Okay, in tonight's video, we're going to look at the last two examples that we skipped earlier. We're on example 4 here. Let's mark the given. AB congruent to FC. That's these two segments. And I have BC congruent to DE. So those two segments. It's just this piece and this piece, so make sure you know what you're marking. We have perpendiculars, AB perpendicular to BE and FC perpendicular to BE. Okay, so perpendiculars would get me right angles. Where is that? AB perpendicular to BE. So that gets me a right angle here. And I need FC perpendicular to BE. So I would get right angles there. All right, I want to make sure I say those right angles. I don't know which ones I need, but I'm going to say angle B, since that's the only one up there. Angle FCB and angle FCE are right angles. If perpendicular, then right angles. All right. When I look at this some more, I'm starting to see triangles that look congruent. I'm looking at ABD and I'm looking at FCE. So I'm kind of thinking I want this right angle right here and this one right here. So I'm going to go ahead and get them congruent. That would be angle B congruent to the angle FCE, I think is the one I want. If you get them all congruent, that's fine. If right angles, then congruent. So if I'm looking at these two triangles, this guy and that guy, I have a side, I have a right angle, I have a side, I have a right angle. Hopefully you know what to do with these two segments. If I have two segments with a space between, you should remember that we can add to get CE and DB. CE congruent to DB, that's adding the same segment. If same seg added to congruent segs, then sums congruent. Now I can get the triangles. I can get triangle ABD congruent to triangle FCE. If you look closely, that is side, angle, side. I know we have a right angle, but it is not HLR. It's side, angle, side, which is why I got my right angles congruent. All right, so now what parts of those triangles are going to help me get AD parallel to EF? Where are they? AD and EF. I need a transversal, right? My options are CF or my options are EB. I hope you can see why I highlight EB. Hopefully you see an upside down F, right? An upside down F would get me this angle right here, which is in the lower triangle, and this angle right here, which is in the upper triangle. I know those two angles are congruent because they are corresponding parts of these triangles. So I'm going to say angle E is congruent to angle BDA because if triangles are congruent, then their corresponding parts are congruent. But now these two angles for these orange lines and this transversal are corresponding angles. They're both in the top right corner. So because they are congruent, I can say those lines are parallel. AD parallel to EF if corresponding angles are congruent, then the lines are parallel. So again, getting the triangles congruent, not bad, but really realizing what angles you need to help you get the parallel lines. And again, use that color and consider all your different transversal options. One more quick one here. We have AB congruent to AC. That's these two. I'm looking at an isosceles triangle, I believe. We'll come back to that. Whoops, I don't need line 2 yet. I have CB bisects angle ACD. Where is that? CB, bisects angle ACD. All right, so let's use the given in order. If these two sides are congruent, I know those two angles are congruent. So angle B congruent to angle ACB if sides, then angles. All right, and now I'm going to use the bisects. The bisects gets me these two angles congruent. That would be angle ACB congruent to angle DCB. If bisects, then divides into two congruent angles, or I should have said if array bisects an angle. But now I notice this is double tagged, right? So do you see that now I can hook them all up? So the question is, which ones do I want to hook up? All right, well, let's highlight again. I need AB parallel to CD. So I have two choices for transversal. I have AC, but I seem to know nothing about anything here by angle A. So I think I'm choosing BC as my transversal. I see a Z, so I think I'd like to hook these two angles up by transitive, because then my Z tells me those are alternate interiors for these lines. So I'm going to hook up using transitive angle B, right, which matched this one by if sides then angles, and then by bisect this one matched this one, angle DCB. That's transitive. And then since these two angles are congruent, B and DCB, I can say AB is parallel to CD if alternate interior angles are congruent, then the lines are parallel. Okay, so again, using these tips, highlighting what you're trying to prove, looking for what angles you need to get them parallel. That's it for today.